Are these associated with the proper? Oh no. What is this? What has this happened here? Arere. Just a minute. Oh, okay. That was just an artifact. Got scared. Anyway. Okay. That's fine. That is also okay. So once you just split, I mean, you have done splitting the geometry, you can just go ahead and inspect whether all of the curves and points are associated with the surface that you want. Okay, so that is a good practice. That afterwards, when you're starting to mesh, you shouldn't get into trouble. Like if you have a stray surface that you haven't separated, you will get. I mean, by default, you'll get a very fine mesh there because of the uh, because of its size. So, and then you shouldn't go there and wonder why this is happening. Okay, so it's good practice to just go and check your geometry first. Okay, so now we have created the. Okay. So to recap, we have imported the geometry for the wing. We have separated the respective entities: the upper surface, lower surface, trailing edge, leading edge, root, and the tip. We have created the far field, and we have created the symmetry plane here. Okay. So until now, does anyone have any doubts in how? Uh,
Not
Pakka?
at all.
Paka.
Yeah. Okay. Cool. Cool. So next we'll since there is still 1 hour left. Do you guys want to take a break for 5 minutes or something? Can what do we do? Another hail raw. You want to take a break?
Okay, boss. You want to continue? Continue.
Okay.
Leave it.
I mean, you guys are not fatigued, right? Because it's already late.
Yes.
So okay. Okay. Fine. I'll continue. So now we'll go into the meshing. Okay. So in the 2D airfoil, you guys remember, right? What and all was done?
Yes, bro. Yes.
Yeah. So these steps here are also similar but not same. And there are some steps that have been added. Okay. So and also a slight change in plan. I will teach you guys how to make a mesh for viscous simulations only. So we'll get straight into that. Okay, so the first thing we do is we set the global mesh parameters. Okay, so we have, oh, before this, sorry, there's one more step. So so you just have to understand this for now. I mean, take it for granted that the meshing softwares that are available in the market, they operate on single precision. Okay, that means the dimensions that are seen by the software is up to a certain number of digits. Say, for example, let's say it's up to 16 decimals. Okay, that defines the precision of the geometry. But solvers like Hyphen and some solvers like OpenForm or some proprietary solvers like Fluent, they operate on double precision. So when you guys were doing simulations in Fluent, you used to get a dialog box first, right? I mean, to put it into single precision or double precision, right? Do you remember? Okay, never mind. So there, that is what is single and double precision. So for solvers like double precision, what we normally do is we scale up this geometry. Is that we make it bigger. And what we do there is we scale in what we do in the solver while we are importing the mesh is that we scale it down. So when you were doing it in Hyphen, you guys remember you were putting in a scale when you were pre-processing the mesh, right? So
Yes,
Yeah, bro.
bro.
Like
Yes, bro.
0.1. Yes, bro.
Yeah.
yeah. So that scale, that number depends on how much you scale up here. Okay, for example, now I mean, usually we scale it up to, I mean, 1,000 times. So that when we import into a hyphen, we scale it down by 0.001 times. Okay. So you can scale up your geometry using this option, transform geometry. Okay. In this, we have translate the geometry, that is move it to a different location. So for example, here the wing is at the point on the leading edge is at the origin. Okay, so you can move that to wherever you want. Here we have rotate the geometry, so you can rotate the geometry about an axis and give it an angle. And then we have mirroring the geometry. That is, if you want a mirror of this on the other side, you can do that here. And here we have scale. That is what we'll use now. And we have translate and rotate. So mainly these four operations. Actually, only this one you'll be using. Others are used in certain cases. That yeah, so in certain cases. So here we have to select the parts which have to be scaled up. So we can select the geometry visually here. Okay, I mean by zooming out and selecting everything. So sometimes why isn't it working? Oh, okay, I have switched this off. Okay, so you do it by doing this, but there is also a better option. Okay, so that is by selecting items like this. Okay, so you can ensure that you are selecting all of them. I mean, all the geometry inside it. So here, whatever is visible only it will select, but here it will select the even the points. I mean, if you switched off the surfaces, it will also select the surfaces. Okay, and then we have the scaling factors here. So how much you want to scale it up in the x direction, the y direction, and z direction. So as I mentioned earlier, we'll be scaling it up to 1,000 times. And uh, if you are the one running the simulation, or no, if you are scaling your geometry to a certain factor, then it is very important that you remember it while you are putting it into the solver. Okay, because right now the dimension of the wing is about 1 meter. I mean, the chord of the wing is about at the root is about 1 meter. But when you scale it up, you'll have it as 1,000 meters. Okay, so that's not a physical case, right? So you don't have a 1 kilometer long airfoil, I mean 1 kilometer long wing, right? So you have to remember the scale also. Okay, and normally the center point is the origin only, but you have options to select the centroid of 2 points, or we can select it using I mean making a point and selecting the point there. But we'll be using the origin here. So now we'll apply. Okay, so now we have scaled this up to uh, 1,000 times. Okay, so to see the difference, this is the scaled down geometry, and this is scaled up geometry. Okay. Whoa. Wait a minute. Far field. Okay. So if I was to measure this points, so if you want to, there's an additional tools in hyphen. So if you want to measure the distance between 2 points, you guys maybe know about this, right? How to measure distance between 2 points, right?
Right, right, okay.
Okay. I was asking a question, but okay. So here you can see it is, I mean, 0.81 meters, the scale, the original geometry. So if you scale it up, you have 810. Okay. So this is now scaled up. So now you can do the meshing easily on this. Also, one more benefit of scaling it up is you can give much larger spacings for the mesh, and that will make it easier to. I mean, that will take less time to mesh because the meshing software doesn't have to go into each and every